Viewers, in today's lecture, we are again going to take up some important problems from the topic differentiation. So here I am taking some mixed problems, and the first one is to find dy by dx if y is equal to x raised to 10x plus square root of x square plus 1 divided by 2. Now viewers, here we have the sum of two functions. So y is given as x raised to 10x, and we can take it as u, and this function can be taken as v. So u is x raised to 10x, and v is square root of x square plus 1 by 2. Now we want to find dy over dx, and dy over dx is du over dx plus dv over dx. Now from this relation we will find du over dx, and from here we will find dv over dx. So let us do it. So from here, taking log of both sides, we get log u is equal to log of x raised to 10x. This is log u, and this is 10x because it is in power, so we take 10x to in front of log, so we have log of x, right? Now let us differentiate both sides. So we have 1 over u du over dx, and here we have the product of two functions. So 10x, derivative of log x is 1 over x, then we have log x, then derivative of 10x is sec square x. So du over dx can be written as, taking u to this side, so we have u times 10x over x plus this is sec square x times log x, right? And if we substitute the value of u, so u is x raised to 10x, and we have 10x over x plus sec square x times log x, right? Now our second aim is to find the value of dv over dx from here. So again see, this can be written as x square plus 1 by 2 raised to half. Now taking log of both sides, we have log v is equal to log of x square plus 1 by 2 raised to half, and log v can be written as half log, taking this half to this side, we have log x square plus 1 by 2, right? So here and here we have applied the rule, that is log m raised to n is n log m, right? Okay, now differentiating both sides with respect to x, we have 1 over v, here we have dv over dx, then we have half because this is a constant. Now the derivative of log function is 1 over x square plus 1 by 2, and then by chain rule we find the derivative of x square plus 1 by 2, which is 2x, and plus 0 because 1 is constant, and it is divided by 2. So we have dv over dx, and here we have 1 over v, 2 and 2 get cancelled, here 2 and 2 get cancelled, so we have x over x square plus 1, and dv over dx can be written as vx times multiplying this expression by v. Here we have x square plus 1, and then we have dv over dx is equal to, as again substituting the value of v here we have x square plus 1 by 2 times x over x square plus 1. Now see, here we have x square plus 1 raised to half, and here we have power 1. So this can be written as x over square root of 2 times x square plus 1. Right? Now this dy over dx is now equal to du over dx. For du over dx we write this expression. So we have x raised to 10x, and here we have 10x over x, plus this is sec square x times log x, and then plus for dv over dx we can write this expression, that is x divided by square root of 2 times of x square plus 1. Right? So this is the final expression for dy over dx. Now let us take this problem. Here we have x raised to 16 times y raised to 9 is equal to x square plus y raised to 17. Prove that dy over dx is equal to 2y over x, and this is a very important problem. Now here what we will do, we'll again make use of the concept of logarithms. So taking the log of both sides, right? So if we take the log of both sides, we have log of x raised to 16 times y raised to 19, and here we have log of x square plus y raised to 17. Now this can be written as log x raised to 16 plus log y raised to 9, and here we have log, and taking 17 to this side we have log of x square plus y. Taking this 17 to in front of log, because log of m raised to n is n log m, and log m into n is log m plus log n, right? So here we have applied this rule, and this is log x raised to 16 plus, because here multiplication sign, and here log y raised to 9. Now applying this rule to this term and this term, we have 16 log x, we have 16 log x plus 9 log y is equal to 17 times log of x square plus y. Now differentiating both sides with respect to x, we get differentiating with respect to x in both sides, we have 16 times 1 over x, here we have 9 times 1 over y, then we have dy over dx here, and then we have here 17 times 1 over x square plus y, and because log of x is 1 over x, and then by chain rule we have 2x plus dy over dx, right? Now here our aim is to simplify this expression. So here we have 16 over x, this is 9 over y, dy over dx, and this expression can be written as 34 times x divided by x square plus y plus 17 by x square plus y dy over dx, right? Now taking this term and this term to one side and taking this term to this side, so we have 9 by y minus 17 divided by x square plus y times dy over dx, and here we have 34x x square plus y minus 16 over x, right? Okay, now we have to simplify this expression. So here if we take the LCM, then we have 9 times x square plus y and minus 17y and divided by y times x square plus y and times dy over dx. And similarly here we take the LCM, that is x times x square plus y, and we have x times 34x, that is 34x square, and minus we have 16 times this term, that is 16 times x square plus y, right? Now this can be written as, this is 9x square plus 9y, and this is 9x square plus 9y minus 17y is 8y, and this x square plus y and x square plus y get cancelled, so we are left with here y. Then we have dy over dx equal to, this is 34x square and this is 16x square, so minus 16x square. So here we have 18 x square, and then we have minus 16 y, right, divided by x. Now this is 9x square minus 8y divided by y. This is dy over dx, and here if we take 2 common out of these two terms, so we have 2, then we have 9x square minus 8y and divided by x. Now viewers, this term and this term get cancelled, so we have 1 over y dy over dx is equal to 2 by x, and taking this y to this side, we have dy over dx is equal to 2y divided by x. So this is the required result. Now viewers, let us take this problem. Here we have to differentiate this function with respect to x. Now this question can be done in using various methods, but here I will prefer the method of logarithm, right? We can also apply the quotient rule here, but we will solve it using the concept of logarithmic differentiation. So let us suppose that this function is y, right? So we have y is equal to 8 raised to x divided by x raised to 8. Now taking log of both sides, we have log y is equal to log of 8 raised to x and x raised to 8. Now this can be written as log 8 raised to x minus log x raised to 8, because log m divided by n is equal to log m minus log n, right? Now here log y, this log y is equal to x log 8 minus this is 8 log x, right? Now differentiating both sides with respect to x, so here we have 1 over y and then we have dy over dx. Here we have simply log 8, because the derivative of x is 1 and this is constant, minus here we have 8 times the derivative of log x is 1 over x, so this is log 8 minus 8 over x. taking y to this side, we have dy over dx is y times log 8 minus 8 over x, and substituting the value of y as this, here we have 8 raised to x divided by x raised to 8 times log 8 minus 8 over x, right? Or this can also be written as 8 raised to x times x log 8 multiplying here by x minus 8 and divided by x raised to 8 plus 1, that is 9, right? So this is the required derivative of this function with respect to x. Now viewers, let us take this problem. Here we have to differentiate sine raised to mx times cos raised to nx. Now here again let us assume this function as y, and this problem can be solved using the product rule, but here again I will prefer the method of logarithmic differentiation. So let us take the log of both sides. So we have log y is equal to log of sine raised to mx plus log cos raised to nx, because this y is a product of two functions. So the rule log say p into q is log of p plus log of q, right? So now this is the power m, and here the power is n, so log y is m log sin x, right? And this is n log cos x. Now differentiating both sides with respect to x. Here again we have used the method, the formula, that is log m raised to n is n log m. Now differentiating both sides with respect to x, we have 1 over y, here we have dy over dx, here we have m is a constant log sin x, so the derivative of log sin x is 1 over sin x, and then the derivative of sin x is cos x, plus n is a constant, so the derivative of log cos x is 1 over cos x, then the derivative of cos x is minus sin x, right? So this can be written as m, this is cos over sine, so this is cot x, and this is minus n times tan x, right? Because sin x over cos x is tan x. So therefore dy over dx can be written as y times taking this y to this side, here we have m cot x minus n tan x, and for y we can write this expression. So we have sine raised to mx cos nx times m cot x minus n tan x. So this is the required derivative of this function. Now let us take this problem. Here we have y is equal to x cube log 1 over x, and we have to prove this statement, that is d2y over dx2 minus 2 over x dy over dx plus 3x is equal to 0. So we'll start with this given function, x cube times log of 1 over x. Now this function can be written as log x cube and here we can write log of 1 over x can be written as x raised to minus 1, and then taking minus 1 to this side we have minus x cube log x, because log of m raised to n is n log m, right? Now we have this function, so differentiating both sides. So here we have the product of two functions, this is u, this is v. Now dy over dx is taking minus sign here, we have x cube times 1 over x, first function derivative of second, then we have log x, and the derivative of x cube is 3x square, right? Now this can be written as dy over dx minus x square, because x and here we have 2, so minus 3x square log x. So this is equation 1. Now again differentiating both sides, so the second derivative is d2y over dx2, that is minus 2x, the derivative of x square is 2x, then we have minus 3, and again we have the product of two functions, so this is x square times 1 over x plus log x times the derivative of x square is 2x, and the second derivative d2y over dx2 can now be written as minus 2x, here x and 1x get cancelled, so we have minus 3x minus 3 to the 6x and log x, and this can be written as d2y over dx2 is equal to minus 5x minus 6x log x, and this is equation number 2, right? Now let us substitute this value and this value in this expression. So the left hand side, that is this side, becomes first we will substitute the value of second derivative, so we have minus 5x minus 6x log x, and then we have minus 2 over x, and the value of dy over dx is minus x square and minus 3x square log x plus 3x, right? So this is minus 5x minus 6x log x multiplying by minus 2 by x, so we have plus minus and minus plus, 1x get cancelled, so we have 2x, minus and minus become plus, 1x get cancelled, so we have 2 3s are 6x and log x, right, and plus 3x. Now this is minus 6x log x, this is 6x log x, so this get cancelled, and minus 5x plus 2x, or minus 5x, 3x plus 2x is 5x, and this is 0, and this is equal to right hand side. So this is how we prove this given expression. Now let us take this very important problem. So here we have y is equal to a cos log x plus b sin log x, and we have to prove that x square times y2 plus xy1 plus y equal to 0. Here y2 is the second derivative, and y1 is the first derivative, right? Now here a and b are constants, so let us start. So first we will differentiate this expression with respect to x. So dy over dx is equal to a is constant, the derivative of cos function is minus of sine log x, and then the derivative of log x is 1 over x, right? So first we find the derivative of cos, which is minus sine, then the derivative of log x is 1 over x. And similar is the case with this function. So here we have b, the derivative of sine is cos, so we have cos log x, and the derivative of log x is 1 over x, right? Now multiplying both sides by x, we have here x times dy over dx, and this is minus a sine log x plus b cos log x, right? Okay, now this x and this x get cancelled if we multiply this whole equation by x. So here we get x. Now again differentiating this equation with respect to x. So now we differentiate both sides. So we can write d by dx of x dy over dx, because we are differentiating both sides with respect to x, and here we have minus a, and again the derivative of sine is cos log x, then we have 1 over x, because the derivative of log x is 1 over x, plus b times the derivative of cos log x is minus sine, because the derivative of cos is minus sine log x, and the derivative of log x is 1 over x, right? Now here if we differentiate, so we get first function, derivative of this is second derivative, then we have dy over dx, and the derivative of x is 1, and we have minus, here we have minus, so here we have minus, so we can take minus common, so we have minus 1 over x is times a cos, here we have log x plus b sine log x, right? Because 1 over x and 1 over x in both the expressions, here in this term also, in this term also, so we take it common, and here we have minus and here we have minus. Now see, this expression is equal to y, so we have here minus y over x, right? For this we have substituted y. Now taking this minus y by x to this side, so we have x times d square y over dx square plus dy over dx, and dy over dx plus y over x equal to 0, right? Now to express this statement in this form, multiply this whole equation by x, right? So if we multiply it by x, we have x square, x times x is x square, d square y over dx square plus x times dy over dx plus x times y over x, so x and x get cancelled, so here we have plus y equal to 0. So this is the required expression.